Hey everyone! Today we're diving into something that sounds super complicated, macromolecules. But don't worry, we're going to make this exciting and easy to understand. Did you know that scientists once didn't believe giant molecules could even exist?
That's right. In the early 20th century, many scientists thought materials like rubber and plastic were just clusters of small molecules staying together. But in the 1920s, a German chemist named Hermann Staudinger proposed something revolutionary, that these substances were actually made of long chains of atoms forming giant molecules, which is called macromolecules.
And guess what? People didn't believe him at first.
Yes, his idea was controversial, but later it was proven correct. He even won the Nobel Prize in Chemistry 1953, and thanks to that discovery, we now have more plastic, synthetic fibers, and tons of materials we use every day.
Okay, let's break it down. What exactly is a macromolecule?
Okay, a macromolecule is a very large molecule made up of small repeating units called monomers. When many monomers bond together, they form a polymer.
Think of it like Lego blocks. One small Lego piece is a monomer. When you connect hundreds of them together, you build something big. That's your macromolecule.
In living organisms, there are four main types of biological macromolecules: carbohydrates, proteins, lipids, and nucleic acids.
Okay, now I think this is the time that we are going to explore them one by one based on their building blocks.
Okay, so first, carbohydrates. Their monomers are called monosaccharides. Like glucose, when many glucose molecules join together, they form starch or cellulose.
That's why rice and bread give you energy. Your body breaks down starch into glucose for fuel.
Second, proteins. Their monomers are amino acids. There are 20 different amino acids that can combine in countless ways to create different proteins.
That's amazing because proteins build on muscles, skin, hair, and even enzymes that speed up chemical reactions in our body.
Okay, so now, third, lipids. These are made from glycerol and fatty acids. Unlike other macromolecules, they aren't always long chains in the same way, but they're still large biological molecules.
Lipids are basically fats. They store energy and protect our organs.
Finally, nucleic acids. Like DNA and RNA, their monomers are called nucleotides.
DNA is like the instruction manual for life. It tells your body how to grow, function, and even determine your traits.
Okay, so now let's look at their properties. First, carbohydrates. Carbohydrates are generally water-soluble and provide quick energy. Second, proteins. They have very specific shapes and function. They can change structures when heated, like an egg when it's cooked. And third, lipids. Lipids are hydrophobic, meaning they don't mix with water. And last one is nucleic acids. They store and transmit genetic information.
That's why oil and water don't mix. Lipids are non-polar.
And when you fry an egg and it turns to solid and white, that's protein denaturations. Its structures change because of heat.
So, where do we see macromolecules in daily life?
And our food, like rice, meat, vegetable, and milk, they all contain biological macromolecules.
Plastic bottles, synthetic clothing like polyester, those are synthetic polymers, also macromolecules.
Even the DNA inside your body that determines your eye color or height that is macromolecule active.
From the food we eat to the materials we use, and even the code inside our cells, macromolecules really are everywhere.
Okay, so macromolecules may sound complex, but they are simply large structures built from small repeating units.
Small building blocks, big impact.
They shape our bodies, power our cells, and build our modern world.
So basically, it is from a scientist's old idea that was once rejected to a discovery that changed science forever. Macromolecules truly are tiny giants. Thanks for listening. See you in the next episode.